Good afternoon, everyone. How is everyone doing? Oh, that's nice. So, welcome to my talk, Conditional Modules and Dynamic Bundling, a Netflix original. And yes, this one is not about GraphQL. Okay, so Netflix. Is there anybody here who doesn't know what Netflix is? Oh, that's amazing. I'm glad that everybody is aware of Netflix. So Netflix is actually the online video streaming service, and we have like wide variety of programs, documentaries, and shows. What is pretty amazing about Netflix is the fact that we are available in over 190 countries, and we have over 150 million subscribers. So yes, hashtag Netflix everywhere. Cool. So my name is Rajat. I work at Netflix. I am part of the Node.js platform team. And what we essentially do is build Node.js libraries and provide infrastructure for our UI developers to actually write Node.js based services. And these are the services that feed all the data to all our UIs, to all our apps. And today I'm here, I'm going to talk about how we do bundling of JavaScript files at Netflix. How we actually challenged some of the common conventions, and we had to challenge these conventions to solve a bunch of problems that we saw at Netflix. All right. So this talk is actually split in like 4 parts. So first, I'm going to talk about the actual problem statement. What exactly is it that we are trying to solve? Then I'm going to go through the problem, work through the problem, and figure out what is it that we want to eventually build, and actually what we actually ended up building. And finally, I'll just end the session with some of the notes around what are the near-term stuff that we want to achieve with our bundling solution. So Netflix is essentially a data-driven product development company. So what does that mean? That only means that at Netflix, we do a ton of A/B testing. We actually do like a ton of A/B testing. And all the data that we gather with these A/B tests, they're all used to make sure the user experience keeps on improving with every iteration. The browser-based app that you see when you log on to netflix.com, or even the television app, like if you have a smart TV, you have Netflix apps out there, or your PlayStation app, all of that is built using React. Okay? And when a Netflix engineer works on the UI, A/B test is something that they have to always take care of, consider it while they're designing their stuff. So A/B testing is really, really important for us. So for example, if you were to log on to netflix.com, this is the UI that you possibly see, right? And as React developers, you must be, it's pretty easy to identify the different components on this particular UI, right? And most of these components are actually being A/B tested. And at a time, we are running so many A/B tests. Some of our A/B tests could be like as simple as just figuring out what the title size should be. At times, we are just figuring out what's the most appropriate image size, or even the spacing between the images. And sometimes it's as minute as the fact that where should the Netflix's end logo be? Like, how do we make sure that our audience actually understands this is the Netflix original series that we are talking about? And all we want people to do is click on the play button and play more videos, right? So as I said, Netflix runs like hundreds of A/B tests. And with all these A/B tests, what happens is every subscriber actually ends up receiving some sort of unique experience. So the UI that I see and the UI that you might see will vary a little bit. So essentially, based on what A/B test cells you fall into, your UI experience actually differs. It's a little personalized. And it's not just A/B test that governs the experience. It's also the fact like which browser you are using, or for that matter, if you are using a television altogether. So that's a totally different experience. But all of these factors actually govern the user experience that you get to see. Let's start with an example. So assume we want to A/B test this particular search box on the top right. So, in a very simple case, this particular search component is what we want to A/B test, and assume we have something like the current search component and the new search component. So as an engineering team, it is essential for us that we are able to bundle together all the dependencies and sub-dependencies of the search component to the user, right? And you can imagine the modular JavaScript would look something like this. So you have your entry point app.js, you have these two components, current search and the new search, and they have their dependencies and sub-dependencies. And the idea here is if somebody is in the current search A/B test cell, that means they get this current search component and all its dependencies. And likewise, if you are in the new search A/B test cell, that means you get the new search and all the corresponding dependencies, right? So you can imagine as a developer what happens. In the code, you have something like, okay, I'm going to import current search, I'm going to import new search, and then somewhere in the code, in your render function, you have this if condition, and you just show one of the search components, right? That's usually how most people do. But what that also means is that you need to have all these files in your JavaScript bundle, because we do not know beforehand which component you are going to render. So you need all these files to be present, right? So at this point, do you guys see some problem out there? Well, yes, we know for sure that there will be certain files which will never get executed just because of the fact that we are only showing one component, not the other one, right? But then, every great story starts with a problem. And when I say that some part of your code is not going to get executed, that's just the start of the problem. The fact is, Netflix apps are like really, really huge. So if we were to combine all these experiences together and we were to bundle them together and serve it out, these apps would be like this huge. So website app itself would be like 10 megabytes, and the one that you see on your television would be like 30 megabytes. And these sizes are after all sorts of uglification, minification, optimizations out there. So as a subscriber, I'm sure you will not appreciate if I'm sending 10 megs down to your browser. And with these bigger packages, the common problems, of course, like the app is slow, there's longer time for the app to be interactive. So essentially what we are saying is, hey, it's actually a very poor user experience. So how can we improve the user experience, right? And here the common convention is, why don't you build smaller bundles and then serve them when you need them, right? So yes, maybe we can build smaller packages. Like maybe these packages can be tailored specific to a user's A/B test. But then, do you really think we can do that? Like, can we really build smaller packages that are like specific to a user's A/B test allocations? Like we have 150 million subscribers. Well, turns out the answer is actually no. And the answer is no, not because of the fact that we have 150 million subscribers. It's because of the fact that we actually run hundreds of A/B tests. And that actually has a few side effects. And let's see how that matters. So when we think about A/B test, we all typically think about two variations, variation A and variation B. But that's not really the case at Netflix. We do not really have just two variations. We run something called multivariate A/B test. So you will have more than two options, more than two variations. Additionally, it's not just multivariate, it's multiple multivariate tests that we run. Of course, at the end of the day, we are running like hundreds of tests. And the way any user gets allocated to any of the test cells is completely random. So as long as you have or you meet certain criteria, you might just be allocated to these tests. So even from our side, at times we do not know what's the user experience a subscriber is going to get. So the next question that we have is, how many packages are we talking about? Like how many packages should we be building and serving with all these unit tests, and they have to be like smaller and cater to those specific A/B test allocation? Well, the math here is pretty simple. So it's just the Cartesian product of all the test variations you have in each of the tests. Okay? So let's simplify this a little bit. Let's talk about just 15 tests, and let's assume these tests have just 4 variants to it. Okay? What happens with Cartesian product is what we're talking about is it's going to be like 4 into 4 into 4, like 15 times. That's 4 to the power 15. Any guesses what this number is? Well, 4 to the power 15 is over a billion. So now imagine, just with 15 tests, we are talking about potentially a billion different combination of packages, right? And these are all going to satisfy the condition that, okay, the user's A/B test allocation is taken into account. Now again, let's talk about 100. So that was 15. Let's talk about 100. So this time the number would be like 4 to the power 100. And that's so huge that I do not know how to put that on a slide. So at this point, the answer to our question is yes, we probably need to serve like billions of different packages. So let me just rephrase the problem statement here. So what we are trying to do is serve billions of smaller packages that are very specific to users' A/B test allocation. Okay? So at this point, the first question as an engineer was, is it even feasible to kind of build, pre-generate these billion packages? What do you guys think? Should we be generating? Can we even generate? Well, that's right. So it's really, really unreasonable to expect to generate a billion packages. So again, we were determined to solve this problem. We were the defenders. We were as serious as Luke Cage and Jessica Jones. And just to be clear, I was the cool guy with the specs out there in suit, okay? So we thought pretty hard about our problem statement. And what we realized was, hey, we actually have a server. And what if we can actually build something that can, combine all these files on the server at the request time? And the only condition that needs to be true is it really needs to be fast. So what we are talking about is really super fast on-demand bundler, right? So can we really do it? So at this point, we look back. We look back at our developers, like how exactly are they keeping track of these variations? Like what exactly are they doing? And we realized most of these user experiences are just gated by a Boolean flag. So for example, with this case, if the new search experience is true, that's when you get the new search component and its dependencies, right? So all of this is actually just governed by one Boolean flag. And that was the most common pattern that we saw. So to make our on-demand bundler, the dynamic bundler, to be really, really fast, we were pretty much sure that we have to do some pre-work. We have to look into the source code. We have to figure out, hey, what are all these Boolean options that we see? And what are the different user experiences that these Boolean values are actually gating? Like, that's the pre-work. If we can do that pre-work, maybe our bundlers' efforts can be just channeled around figuring out, okay, this is the list of files, just combine them and send it back to the user, right? Maybe our bundler would be fast. So at this point, we were very clear. So we had to deal with two setups. Like first is the build time and the other is the request time. So the expectation here was, okay, in the build time, what we are going to do is we are going to do some static analysis. So it's all magic. Go back, look at the code, figure out what those, the Boolean values are. And at request time, just use this information to do just one thing, which is get all the source, combine them, and send it over. So having said that, what we did was for the request time, we said, we are going to use Node.js to build our server side, to build our on-demand bundler. And for the build side, we are going to use Webpack. And the reason we chose Webpack was Webpack actually has pretty nifty hooks, and it allows you to customize all of its behavior, all of its bundling behavior. It also has a great ecosystem around it, and most of the Netflix developers, they were very comfortable using Webpack as well. So all of those points counted towards it. So now talking about the build process. So what we said was, okay, how about we let Webpack read our source code and figure out all these various stuff, like what are the different Booleans, what exactly or how exactly does the dependency look like, and then dump it into a serialized form, an artifact, right? So the expectation here was artifact will have the knowledge about how your dependency graphs looks like and what are the different conditions which are being blocked, okay? And for the second part, we just take the artifact, give it to the on-demand bundler, and let it process it. So now we know what we are talking about, like what exactly is the system that we are talking about. This is the exact system that we eventually built. And before we actually go in detail, I would want to talk about the most important aspect. So these are some concepts which are important to understand how this all of it works. So the first thing that I will talk about is conditional dependencies and the conditional dependency graph. But before I go in there, let's talk about the most important piece, which is the artifact file. So we need to understand what goes into this artifact file, right? So first and foremost, the most important thing that needs to be in this artifact file is the dependency graph itself, like how are different files related to each other, right? So at that point, this is how your dependency graph probably would look like, right? The next thing it needs to know is all the metadata, all the Boolean values that exist in the code, and what are the files that it actually blocks from getting included or actually forces something to get included, right? So when you apply when you figure out all the metadata and you apply to the same graph, it kind of becomes a conditional graph, right? So all the red nodes that you see are probably blocked by some variable, right? And when you start storing this information, what you essentially have is a conditional dependency graph. And at the end of the day, what we wanted Webpack to do is actually output this conditional dependency graph, serialize this and put it down into a file. And that is the file what we want to call as an artifact. So we pretty much understand what conditional dependency graph is. So, but something that we also need to understand here is what exactly is a conditional module, right? So in this particular example, so app.js depends on new search, and new search depends on all the dependencies. But the fact is, app.js can only depend on new search when this condition new search experience is true. So in our language, what we started to call was new search experience is the condition, and the new search component and all its dependencies would just form one big block of conditional module. And when you apply this particular metadata to your dependency graph, what you get is a conditional dependency graph. Okay, so as engineers, the next problem that we had was actually how do we mark modules or files as conditional? Like JavaScript doesn't really provide something like that, right? And we have to make sure Webpack actually understands this. Like how do you make Webpack understand all of this new stuff? Well, to do that, we actually introduced two different syntaxes. And these are not JavaScript syntaxes. These are not really like valid stuff. This is something like special markers and annotations that we started to add to our code. So the first syntax was @condition followed by whatever your Boolean name is. So what this means here is the new search file is announcing that, hey, on-demand bundler, anytime the new search experience is true, that's the only time you can include me. So the file itself is announcing that fact. That's the first syntax. And the second syntax is this funny looking $conditions.new search experience. So essentially in this case, the parent file, which is the app.js, is able to say that, hey, when the new search experience is true, that's when I'm going to require new search component. When it's false, just go and pick the current search experience, right? So these two different syntaxes allowed us to cover almost all the cases of specifying the dependencies as conditional. Having said that, the next question that we have is like, how is Webpack ever going to build this dependency graph? So now Webpack understands these special markers, and what we did was we relied on Webpack's Webpack parser's program hook. And basically this hook, what it does is any file that it parses, it gives you the AST. And once we have the AST, so AST is abstract syntax tree. Basically, it looks at your code, figures out, in a very structured fashion, like what your code means. And we just look for our two of those special syntaxes. And every time we saw that, we would just instruct Webpack to, hey, can you just keep a note of the fact that this edge or this dependency is now conditional. So that's all we were doing with our plugin. The next thing that we did was, of course, utilize the emit hook to actually serialize all of this information. So at the end of the plugin run, you would always get back a serialized file. So essentially, this is what happened. We have Webpack with our plugin running. It would store all the conditional dependency graph information and then output a file. So having said that, we know our build process is done. We have an artifact file. But now comes the most important part, which is bundling as a service. So now we have the artifact file. Now we also need to make sure we have the system to serve the right packages, right? So at Netflix, our service, which actually does this, is called Codex. So you can imagine that anytime somebody watches Netflix on netflix.com or using our app, there's a request that comes to this server for the JavaScript assets. And this server is now capable of actually delivering the JavaScript bundle. And this bundle will be specific to whatever your experience is that should be unlocked for you. So the question should be like, how the hell are we resolving the conditional dependencies now? I mean, it sounds simple, but how the hell does Codex know that, okay, these are the experiences to be unlocked? Well, the secret sauce here is actually the URL. So the URL that we use, or that the Codex actually utilizes, contains all the information that it needs to go and start resolving the dependency graph. So if you take a look at the URL, it's actually templatized. So it knows which Teams app are we talking about, which version of the app, what should be the entry point from where I should start parsing start resolving the dependency graph. And at the end, you have comma separated values of, okay, these are the conditions that you can unlock. So if somebody falls in like 50 A/B tests, those are just encoded and sent back to Codex, right? So this URL is basically self-sufficient. And this example out there shows, okay, it's a web UI app. We are looking for v3 artifact. So Codex is able to go and locate this artifact. And then it realizes from the URL that, okay, the new search experience is true. The smart playback is true. So these are the two different experiences that we can unlock for this request. And then all it has to do is start resolving the graph, right? And once the graph is resolved, it just sends back all the files together. Now let's talk a little bit about how this resolution algorithm works. This resolution algorithm itself is pretty simple. In the sense, all you have to do is walk the graph and keep walking till you actually hit a conditional edge. And anytime you hit a conditional edge, just look at what are the Boolean options that are true. So in our case, like in this particular example, when we start traversing this graph and we see that, okay, you know what, we have two conditional edges. One says the new search experience needs to be true to traverse it, and the other says the current search experience needs to be true to traverse it. And in the Boolean flags that we have that are enabled, so those are the UI experiences that we can unlock. It says new search experience is true. We keep walking down that path. And then we again stop at the next set of conditional edges. And at this moment, you see that smart playback is true. We just include that while we just ignore smart session. So at the end of this traversal, what happens is we've just taken this graph and pruned it into what is required for that particular request. So at this point, I'm pretty sure a lot of you must be thinking, hey, isn't this like really slow? Like you have 2,000 files, you're going to parse the whole graph again and again. Like, isn't this really slow? Well, when we started, it was definitely slow. But as of now, we've actually optimized our graph traversal a lot. And we have managed to bring down our response times to be like less than 70 milliseconds. And there is a lot of memoization that we had to do. There were multi-level caches, even caches between like being stored at like each instance level on the server. So a lot of effort actually went into it to bring it down to like 70 milliseconds. As a matter of fact, our 95 percentile latency for TV UI apps is close to like 100 milliseconds. So that's not too bad. The other interesting point here is the URL, as I said, is giving you all the inputs to the Codex server. So if we get the same set of values, the output is always the same. So that means we can actually cache the bundle on CDN. And actually that helps us a lot because we are then processing one request only once. And if we get any next time it's the request for the same setup, it just goes through CDN. So in summary, what happens is developers use our syntax. They explicitly mark, okay, these are the different conditions, and these are the different UI experiences that are gated. We run the Webpack build with our plugin. It looks at your source code. It generates the artifact. You give that artifact to your Codex servers, and your Codex server is now ready to take traffic. So this is the exact system that we built. Building all of this wasn't easy. We actually ran into so many issues, starting with performance issues, starting with knowledge issues. Like a lot of stuff was unknown to us. Webpack itself is not something very easy to understand. So when you start hacking all of this, you do tend to talk about trade-offs. And some of the trade-offs to achieve this is what we want to fix going into the future. So we do want to leverage all of Webpack's ecosystem, right? But as of now, there are certain things that are broken. And the biggest thing is the developer experience in some form. So for example, our developers, they cannot use Webpack dev server because now it cannot be served through Webpack, through a regular web server. The serving of the files always has to happen through Codex. So that's a broken piece. The second thing that we ran into is we were not able to generate the source maps correctly because now the source is actually changing. Like for every request, it's a different thing. So these are the primary two pain points that we are working on, and we are still solving it. And even outside of all of this, I think something that our team enjoys doing is making sure the resolution algorithm is still fast, because I think that's the biggest win that we ever got. Bundling under 70 milliseconds on demand. So that's all from me for today. Thank you so much. You guys have been a lovely audience, and I'm available on Twitter as Rajat Kumar, and please feel free to follow me. And yeah, happy to talk and take questions after this. Thank you. Thank you so much.
Recording was brought to you by Twilio. We allow you to integrate different means of communication such as video, chat, or SMS into your React applications. If you want to learn how you can send SMS directly from a React chat, check out this video on the right or go to our Twilio YouTube channel. And if you want to watch another React India talk, we picked one out just for you over here on the left. Thanks for watching.